Okay, so today we're gonna learn something that took me about close to 9 months to understand. Yes, that's a long time. I'm going to have, this is video number 1, and then video number 2, I am going to show you how to do certain things to your water. Yes, water. As we already know, water is the most important element for living beings or living things. Now, not a lot of people talk about this. Isn't that kind of strange that it is the most important element, but not a lot of people talk about it? And they worry about deionizing, alkaline, filter, purified, or even what come out of your tap water or bottled water. But there's actually something else in there. And is radiation. Yes, all water have it because all water attracts to it. And because of that, there are actually a lot of them in there. And as I explain this, I'm going to explain the best I can, of course. The best how I understand it. And I will also draw you some doodling too. But first, we're going to talk about this right here. This actually almost took close to 6 months to understand this. This is an avocado. And this one grew. But this one didn't. It grew and it died. You can tell. Okay? It grew and then it died. But look at the water. I actually saved this water for a long time to make this video. Now, in this lifetime, before I go into this, in this lifetime, you and I and the rest of the world cannot change water, regardless what we do to it. If you add salt into it, if you add water to it, you add whatever it is into it. You cannot change water because water stays the same. Now, as we know, water, I'm going to draw you something. A water have an oxygen, liquid oxygen, and hydrogen. Okay? And the molecule would look something like this right here. I just draw it. Okay? That's the oxygen and that's the hydrogen. And it binds together. And notice, hydrogen have a positive sign. And oxygen have a negative sign. So they bind together because positive and negative electrons. Or ions. And when it binds together, it becomes an element, which is water. Now, what if I tell you that other stuff can attract to it? Okay, let's make an example. Salt. Let's say salt can actually bind onto the water. It will bind to a certain amount. Let's say this is salt. I'm going to put an S, okay? Once that is done, it will no longer able to bind, so it's separate from here. Let's say if you add more salt than the water, these will no longer able to bind. So if you actually mix all this together, like in a big thing, Like sort of like it becomes an atom. Although it's not, but let's say a big huge element, I would say. Okay? It becomes sudsy, but it won't bind. I've learned this when I was doing my mixture of water and salt, because I wanted to drop it in the toilet, and I want to mix more salt in my water. But no matter how much salt I put in, the water stays the same. It won't go further than that. That's when I made my confirmation, is that no matter what you do, you cannot mix further than that. You cannot add more to something that is able to not to hold. Sort of like a weight. Like, let's say you have a cup. Okay? Let's say you have a cup, and that cup is filled. No matter what you do to that cup, you cannot add more things to it. Well, in this case, it works the same way. Okay? Now, what is in here? Well, water. First of all, it's water. What binds them together? Electrons. It binds them together to create water. I will show you all that later in another video, how they actually bind. You can separate them and you can bind them. But the process to make this is really hard. Harder than you think. And a lot of people don't know how to explain that one. I will explain how water actually becomes water. It is easier to separate than it's actually turning hydrogen and oxygen together to bind them. Very hard. And it takes a lot of electricity, or ion, positive ion, and neutrons to make something like that. But anyway, that's another video. So we have this cup. Okay? Now, water's in here. Just pretend all these zeros is water. What happened when there's positive and negative ions? Well, they actually comes through here. Negatives, and they add on to it because it attracts to that. Okay? So now we have a lot of positive, negative ions in that water. Here's an interesting concept, and here's what I found. If you leave this for a while, right? In like few days or a week, it becomes stale. Well, how can water become stale? It is impossible. We already know that. It is impossible. We were taught that this water becomes stale. Sorry. No matter what you do to the water molecule cannot be changed. You know that. I know that. The whole universe agreed to this. And if you don't, you can experiment that yourself. No matter what you put in here, once a certain amount is done, they call it gluons. Once a certain amount is done, it cannot add on to more than that. So, I used to observe this. And I said, how come water becomes stale? Water cannot become stale. No, sorry. The world going to have to rewrite history again, or physics again. And physicists going to have to study this in order to understand. Sorry, but you cannot change water. But you can change what is in water. You can take out what's in water. And what did I just say a little earlier? Ions, positive and negative, and neutral, or neutrons. Okay? They call it positrons, and which is positive, protons, okay, to make the electrical charge. And we already understand that if you stick your hand in here and I put electricity in here, eventually you will get electrocuted because it's act as a conductor. It is not a conductor. It's act as a gap or a bridge. Sort of like if you're walking over a river. Without a bridge, you cannot walk over a river. So basically, the water is actually a bridge. So if I put my finger in here and you put electrical, like positive and negative 120 volt in here, I will get electrocuted because you made a bridge with water. Well, water absorbs that. Water, they call it conduct. But it's actually not. It's actually transferring all those energy through it. And because electron moves so fast, you get electrocuted really fast. Well, in the case of this, instead of salt, what if I gave you the positive ions and the negative ions, which is called positrons? That's what they call it. But it's actually, they are negative electrons and negative and positive electrons. Okay? Simple as I can say it so people can understand. It is more complex, of course, because we're getting into nanoparticles here. You know? So, how does it water becomes stale? They call it stale. But here's the concept to that. Water cannot be changed. What is in here that changes? Well, I just told you earlier. Positive and negative ions, which is electrons, or radiation. Okay? It goes in here. And guess what? All this time, this plant right here has been living. How? What does it do? I'm going to zoom out just a little bit, okay? What does it do? Here's its kind of nutrients. Here, it picks up the water. But here's the thing. How come this one died? Because I didn't change the water. But hey, wait a minute. How come we have the food here, which is the nutrients, right? But it still died. I didn't change the water. And I will be the first one in human history to understand this, and I will explain it to you. And because I understand this, I understand further than that. And because I understand further than that, video number 2 is going to be so important to you. If you are one of my subscribers, remember, these 2 videos for you. And yes, it will help you with your health. It will help you with a lot of things. I made it huge. I can't even say enough huge discovery. Okay? By observing this and learning, and it took me 9 months to actually learn something. So, this here contains positive and negatives, electrical charge. What that does, it draws it up. It attracts. And I say that attracts. Look at how it looks. It attracts the nutrients, which is like, if you're into gardening, you know phosphorus is important. A few other elements is important. A lot of elements is important. Metals. I call them soft metals. Okay? Not hard metals. It's soft metals, which we need. We need soft. We don't need hard. Even salt. I consider salt as a metal. Yes. Because here it is. If it's not metal, it would not be able to bind. Get it? I call it metal, okay? Please don't quote me on that. But I call it metal. Even sugar. I have a container of sugar. Even sugar. Yep. All the elements in this lifetime. They are hard and they are soft and they are in between. You and I know that. Well, the nutrients that they need is actually in here. But they need the positive and negative ions to actually bring that. Because it's metal. And it feed it to the tree itself. Because I didn't change the water here. It took it all. And now this water does not have negative and positive no more. So it looks something like this. Just plain water. Because this thing took it all. So eventually, it has no more positive and negative ions to bring the nutrient up. Everything in this lifetime needs this. Here's the thing, and I will be the first one in human history. These are actually extra. If you have an extra in your water, your water is actually bad. You need that water. And yes, I know how to remove it. So, they worry about, like I said before earlier, they worry about distilling it. They worry about deionizing it. They worry about alkaline, adding more alkaline in the water. They worry about filtering. All that is important. But this, they forgot that they do not understand, and I am the first human in history, and this is the first video in history to understand this. Yes. I will prove it to you even further. Here's an example. How does this dry seed to become a plant? What does it need? I just explained it to you earlier. It needs positive and negative in order to give that spark to grow. Yes. Yes. I will be the first person in human history to explain that to you as well. A dry seed is nothing. If you put this water in, it won't have a chance to germinate. But if you put this water in, it have a chance to germinate. Why? It's because this water have nothing in it. This water have something in it, and I explained that earlier. Okay? So now we understand a little further between these two, right? I'll go even further to prove my theory, and I have already proven. And yes, I've been experimenting this water, and I'll show it to you. It's behind there. Water is water, right? Look at this. How come there are actually less radiation in here? Okay? But this water have a lot of radiation. Look at that. Look at how cloudy that is. I did something to that water. This water is, I have not done anything to it. I'll bring it really close. Let me zoom it out. So, look at that. You see all those evidence? And yes, I will show you how to experiment this as well. Because theory has to be proven, right? Look at that. If you look at this one, look how small it is. There's nothing, barely anything in there. Yes, I have made a huge discovery. And this water here is very beneficial. To you and I. Oh boy, you don't even want to know that, how to do that. I will show you the second video because, like I stated, this is the first video and this is an introduction of what I have made a discovery on. Because of this plant, how this plant is using, which is radiation. Radiation is what bring the water molecules up. But because of that, the water molecule is trapped in here. Radiation escape. And that's how water is able to rise. Please remember that. Radiation. Remember this too. When I said it in many of my videos, radiation plays the biggest role in the universe. This is another one of them. Radiation is what brought all those little molecules up. And they get trapped in there. But here's the thing. Because this water here, I removed that. That's what this water is. And because of that, you don't see a lot in there. And you can leave this on forever and you will see less. Because I removed most of it. This actually sitting here for like 2 days. But here's the difference on that. I'll bring it really close. Both of them. Here's the difference on that. You see the difference on that? One is clear and one is cloudy because there's more radiation in here than this one. How is that possible when water is water? But I am able to figure something else. You want to experiment this? Take a glass jar. It has to be in a glass jar, okay? And put about 3/4 of it in and close it. Leave it for about 2 days, because this is about 2 days. You will know how much radiation is actually in your water by observing up here. Okay? You can do this. And you will be able to know how much radiation's in your water. Or positive and negative ions or protons. Okay? A proton is when they fuse together. When they separated or when they attracted into here, they are kind of separated, so they're actually positive and negative ions. Okay? That's how I understand it. And all through that, because I understand something, all through that, this plant right here taught me the biggest lesson of water. When you put enough water in here and there's not enough space, you can still see it up here, but you won't be able to, because you're not allowing it to have a little air. Air is what helping it to draw it out. Or in this case, I took, I don't know, maybe 1/3 of it out. Okay? But even when I took 1/3 of it out, it's little tiny little bit left. And I believe this is from the environment, not by the water itself. I removed it. And yes, I will show you how to remove that on the second video. And once you remove that, you will drink this. You do not want to drink that. You want to drink this one. And when you drink that, mystery from your health, yes, I say mystery from your health, will know the difference on that. This water, even though it's just regular, plain and simple, it's actually hurting a lot of people. Yes. Water, this water here is actually hurting a lot of people, and they don't even know it. And I will be the first one in human history to say that water can actually hurt you. It helps you, but actually radiation water, or positive and negative, extra, just like I draw about salt earlier, can actually hurt you. That water can actually hurt you. This water can actually hurt you right here. Plain and simple. But when I remove the electrons or the positive and negative ions out of there, it will become even more healthier. Yes, you heard it correctly. I have made a huge discovery about water. And yes, I will share it in my second video, because this is an introduction. In order for people to understand, I have to make an introduction like this. And the second video is going to be a lot shorter. But in order for you to learn something, I have to make an introduction video. Okay? So, get ready for the second video, because I'm going to teach you how to make this water right here. And this water will change your life. I promised. I made a huge discovery. So, I will see you in the second video. Okay?